morning, Chairman and ladies and gentlemen. My name is Yu from EDF Energy UK. So today I present this paper. It's not sort of research, just to justify the software we are using is correct. Firstly, I'm going to very quickly to tell you some background about this, why this has been done. Then I'm going to go through review the J2 ICT definitions, correct definition should be, and abaqus current definitions, and then do some numerical validation, and then based on the validation results, give some guidance for our engineers to use to calculate J and safety correctly. So today, I publish that here to share with all of you. Why EDF Energy Nuclear Generation Limited is the largest nuclear electric generator in UK. We provide 20% of electricity in England, Scotland, and Wales. So we run 8 nuclear power stations and 15 reactors. So 14 of them are AGR, that's gas-cooled reactors, and one is a PWR. You ought to support safe operation and life extension of our nuclear power stations. We perform structural integrity of components of the nuclear reactors inside the company. To do so, this company from many years ago seized the time and start to develop the assisted procedures. One R6, that's for the general French assessment procedure. Another one is R5, that's for structures operate at temperature beyond the creep region. That's R5 and R6. So in R6, the French assessment is performed using FAD, the failure acceptance diagram. So if you use this method, you don't need to calculate the J load, because you only use K and limit load. But R6 allows you to use direct FE calculation of J, then directly compare the J with your French calculus. And in R5, the creep crack growth is calculated using the creep crack rate. And the creep crack rate is a function of CT or C star. That's based on the creep conditions. And C says T for a long time, and we come to C, change to C star. In R5, we give some simplified method to calculate safety, but also allow to use direct FE calculation for safety and assessment. Okay, we are nuclear industry, so nuclear safety is our first priority. So we have to guarantee all the calculate parameters used in our safety case is correct. In this case, we need to give clear guidance to engineers to use software, and also software must be validated. So this is our nuclear industry. Okay, we go to the definitions. Okay, for pure mechanical load, we know that the rise gel in abaqus lasts for a long time, and for combined mechanical load and residual strength. And when I worked in empiricology, we developed a new definition for that, for combined residual strength and mechanical load. So this term definition is clear. This is the rise J, and extra term is for initial strain terms like that. But this concept is a proportional boundary. So this is the assumption. So here, still for strain density, we still calculate to use mechanical strain, but have to have a correction for pre-crack accumulated plastic strain density. That's part of the cutoff. And you are numerical calculation from FE and the initial strain. Basically we know, but we don't know the exact value. So how can you extrapolate that? And the correct method is that the total strain minus elastic strain at an initial state. That initial state you can understand that the state without crack, but with self-equilibrium residual stress figure. That's the state you have to select. Okay, now look at the abaqus. In abaqus version 610 and lower, it uses the rise J plus thermal strain external. So this one is basically correct. We have so many years, and the strain density is still calculated in the mechanical strain only. And this one is path dependent when you have a residual stress. And in abaqus thermal version 6.11 to 14, then we said, okay, we include some terms. We have checked our definition like that. So, and this should be path independent when you have a residual stress. And strain density is calculated in this abaqus manual, in this one. But they will say if we should have the correction for uncrackable in the particle or not. And how the initial strain is calculated, we never tell. And safety, so correct safety should be this, because this equation is path dependent, so only the attractive value is correct. And this is strain energy density rate, calculated based on strain rate. Check, this was converted into domain integral like that, but doesn't mean this is path independent. This is still path dependent. Correct value must be real correct. So this area must be very, very small. In abaqus version 11.14, abaqus menu said, okay, because of residual stress, we have one additional term, but never tell you what does that external additional term like, or looks like, or something, whatever. So we need to find out. Okay, validation. I cannot tell all the details. This is how I did that. Firstly, I developed software as abaqus post-processing programs. So one used to calculate the J, another one is K. Now, for me, it's not very different from when I developed my new definition, and I can do the calculations quite easily. But these two programs basically used to simulate abaqus. Or, of course, you can do the correct calculation. Then I designed French mechanics cases for various residual strains. So particle deformation induced or initial conditions use abaqus to improve and thermal of many cases. Then I do calculation use J and safety using abaqus and self-developed program on that. Then compare the two to many cases and to infer abaqus J and safety equations to guess abaqus equations. give one example like that. So this is the J calculations for case 2-1. This is the contour number. This is the rise J without any corrective cosine the residual space. This is the abaqus calculation. It's very good path independent. This is my calculation. You look at that, it must be exactly same, digital by digital. Exactly same, not to close. But for this case, rise J is path dependent. Abaqus is path dependent, but different from rise J. But use my program can exactly copy abaqus raw method. But if I change my calculation into the correct function, this is a path independent. So this gives some idea. Means the equation I guess is exactly the same. So use the same method. So, but you can imagine I have to calculate many cases. Okay. Then what do we found that? Abaqus equation now, the definition equation is the same, exactly the same. This is the same as I defined published in 2010. But be careful here, abaqus equals 0 doesn't include thermal strain, but for my definition, my equals 0 include thermal strain. So it's basically the same, different formation. And abaqus strain energy density is calculated by the elastic part plus elastic part, then minus the plastic part at residual strain state. When you calculate it, it asks you to point out which state in your upper residual strain. So this is one. That means abaqus does do the correction. Okay. Now the initial strain calculation equation, I guess, is like that. It depends on the state you define. Residual strain state you define. For 0, it uses this one. For non-zero, it uses this one. That means if you follow abaqus instruction, for each 0, if you use non-zero, that will complete 0. It's okay. I need that. So from the equation, I can find I listed all the program I thought. I'm not going to go through that, all these people. If you like, you can read that and verify it. I believe some of these function error, theoretical, some of them is software part. And safety, that additional term is like that. This term basically is for J. So it's completely wrong. Why? Because safety is calculated based on strain rate. Initial strain is constant. Its rate is called 0. This term is non-necessary items. Okay? Don't. Then I generate guidance. I don't effectively rate that all in the paper for J and for safety. So which for safety basically tell you how to avoid that extra term being included. For some cases you cannot do that you have to use old version, the new version option. Okay. Conclusions. Function errors and code bugs have been found from this application. The guidance is developed for you to correctly use the software. I mean, you don't say, okay, this function is go away. You can still use it, but be sure to use it correctly. If you do calculation, read my paper from some information. I will contact abaqus to report all the problems we have found. But abaqus, through many times discussion, they agree, okay, we accept all your findings are errors and bugs. What they do is they agree to do all the correction in their 2017 version. So that way, next year if you have a new version, I'm going to test that again. So that's it. Thank you very much.